Hello everyone, thank you for being here. My name is Iñigo Uriarte. I am from Ingeteam Power Technology, and well, the topic I'm going to speak about is probably one of the questions that you will hear and you will make your colleagues more often during the next 2 days, and it's how do we make green hydrogen competitive. I will not give you the final answer because it's a complex topic, but I will try to explain you what's Ingeteam's vision on this topic and how do we intend to push the value chain towards this direction. For those of you who don't know Ingeteam, we are a company expert in power electronics and power conversions. We are a OEM. We manufacture power converters for any sector where you need to convert power, electrical power, renewable energies, hydrogen sector, but also other sectors like industry, railway traction, marine applications. So everywhere where you need to convert electrical energy, that's where Ingeteam is present. Okay, so going to the main topic, how do we see or how do we intend to make green hydrogen competitive? First of all, we seek for simplicity. We seek for reducing components, reducing complexity of plants, making designs easy that we can repeat. That's why we select between different technologies that you can find in the power conversions. We select the one that we are using, which is IGBT technologies. I will not go to enter into depth into the technologies. For anyone that you want to speak more in detail about this, you are welcome to come by our booth and we can discuss more deeply. But mainly, as in electrolysis, you can find different technologies like alkaline or PEM. In power conversions, you also have different technologies. You can find mainly two main technologies that you can find in hydrogen projects. That might be thyristors or IGBTs. We have both technologies in Ingeteam, depending on the sector. But for green hydrogen, we believe that IGBT is the right one. You don't need to add any additional filtering elements, any additional reactive power compensation systems to be able to connect to our grids, and that's one of the main reasons we chose to go with IGBTs and no thyristors. Next aspect, or the next driver that drives our design of green hydrogen converters is the standardization. Okay, it's obvious that if we want to have competitive components in the electrolyzers and in the electrolyzer value chain, we need to choose standard components that allow us to have competitive costs and also high quality. When we designed our first green hydrogen converter, or the first converter for green hydrogen sector, we decided to design a converter focused on the green hydrogen necessities, but using the same components that we are using in solar PV converters. We have a very big market in solar PV. We have access to economies of scale, very competitive costs. So what we did is we take the same components and we rethink the converter to meet the green hydrogen sector needs. So that's the next one. The third one is modularity. Also comes very related to the mindset that we can have in solar PV sector. We have modular parts in the components, easy to replace, easy to manufacture in blocks, easy to simplify the design. That allows us easy maintenance, less operation costs, and also makes increase of the availability of the converter, reducing times for repairs or any kind of maintenance that we can have. Also, we seek for repeatability. One of the ideas is that we don't want, or we wouldn't like to have one different converter for each project. Of course, there will be some features that we will need to adapt depending on the location, depending on the electrolyzer, but we want some design that our clients can repeat in all their projects. Don't matter if it's in the US, if it's in Europe, if it's in Australia. We want the same converter, more or less, that can be repeated with reducing the engineering costs of every project. Next one is scalability. That's also one of the advantages of the IGBT technologies against the thyristor one, since we don't need to engineer one filtering system, one reactive power conversion system for each plant. We can use the same building block for 1 megawatt plant, 10 megawatt plant, 100 megawatt plant, or even 1 gigawatt plant. Of course, there will be some different engineering and efforts at plant level, but the power module will be the same. Just we will have more or less units, but it's completely scalable. Very important part, and sometimes it's a bit forgotten during the initial steps of the projects, and it's the robustness. Here is also one advantage of using the same components that we use in the solar PV plants, with gigawatts of converters installed all around the world. These are designed to be robust, not to fail, to be operating in very harsh environments, and to last long time with minimum downtime. And last but not least, power density. And this is a requirement very specific for this sector. Very early in our work in the green hydrogen sector, we noticed that we needed a lot of power in a very small footprint, more than what we can have in other sectors like solar PV or battery energy storage applications. So that's why we designed a much more compact converter. We removed components that we didn't need. We thought we could put more power in the same space, and that's why we came out with our converters for green hydrogen sector. Here is what I'm talking about. This is our solution, our current solution for the green hydrogen sector. Depending on the application and depending on the case and the electrolyzer, we can fit up to 13 MVA in only 40 feet. As I said, it's based on solar PV components, but removing everything we don't need, replacing elements, and making it very compact, almost double the power density that we may have in solar PV rectifiers. Also important to remark that everything is designed and built with UL and CSA listed components, suitable for projects in the US, and in Canada, in North America in general. But this is not it, right? We are in a very quick growing sector. Every day we find new requirements, and we think that we must not have a fixed solution, because we need to keep an open mindset, be open for new requirements. Every time clients come with new needs that we didn't think of before. So a good example of this is we started with the Electrolyzer converter. That's the one that you saw in the previous slide, but that was based on based on the technology that we use in solar PV, and that could only reach 1300 volts DC. So very quickly we need to make modifications to launch the Electrolyzer high voltage 1500 that reaches 1500 volts in DC. That's already into market. We will deliver first units end of this year. And we are working every time we are working in new solutions. Some of the examples are a full water converter. This came because we had a full water cool converter. This came because we had some requirements from many projects, like noise reduction or installation indoors, that with an air cool converter it was difficult to meet. So we decided to develop a version of fully water-cooled. Also DC-DC converters to connect directly electrolyzers to solar panels, and then the next generations of converters will be of higher powers and higher power density, because as I mentioned before, this is a application that has big demands in power density. So this is just a few examples of the fact that we need to be, and we know that we need to be open to new requirements. We don't want to have a fixed product and ask our clients to adapt their plant around our converters, because we know that that's not the solution towards competitivity. We want to understand the needs of the plants that maybe tomorrow are different from the needs that we have today, and adapt our solutions to the needs of the sector. To end with the presentation, just a few key figures of Ingeteam. We're a company from Spain, present in 23 countries right now, with more than 5,000 employees worldwide. As I said, in many sectors, not only in renewable power, but also in industrial applications, railway traction, marine industries. And this third point is very important from my point of view. Ingeteam was founded by 4 engineers, 4 entrepreneur engineers, and this mindset is still very present in the philosophy of the company, okay? In the culture of the company. We like to be always seeking for new technologies, new solutions, being technological, not only suppliers and OEMs, but also technological partners to our clients, and be present in all the phases of the life of the projects. Long experience in the electrical sector. And to remark, for those of you that don't know us, we are, as I say, we are a company from Spain, but we are also based in the US. We have a factory in Milwaukee, so we don't only have commercial activity in the US, but also converters production, and also all the after-sale support that a project may need. Commissioning teams, spare parts. We have spare parts in Milwaukee. We can also provide maintenance and operation service of the converters in whole North America. So that's something important for North American market. And to finalize, a few outlines of the experience and of the references of Ingeteam. More than 28 gigawatts of PV converters installed worldwide, more than 50 gigawatts of wind converters, 1.2 gigawatt of battery energy storage converters, and focusing on hydrogen. Right now we have a project portfolio of more than 400 megawatts, and from this, more than almost 300, I think, are in North America, between the US and Canada. So wide experience in North America, not only in PV, but also in hydrogen. For this, from this 425 megawatt, 3 projects have been already delivered. The rest of them are still in different stages, engineering phase, production phase. Okay. So that's all from my side. I didn't leave much time for questions. Apologies for that. Well, we still have half a minute. Otherwise, any one of you that may have any question, you can meet us our booth A22, which is on the other hall next to the code check. I know we don't have time for questions, right? Oh. Any question? No? See you later then. Thank you.